Up first is the concept of classification and marking. It's great if we can tell our Cisco devices that, hey, I want you to treat this type of traffic, whether it's live migration traffic or iSCSI traffic, I want you to treat that traffic in a particular way. But the question is, how exactly does the device know that, hey, this packet is for iSCSI? I mean, I suppose we could in some way drill deep into the packet and take a look at the header information and maybe even what's inside the payload and try to figure out, is this an iSCSI packet? But yeah, that's not really the best way to do it. So usually what we want to do is we want to simply tag that packet, whether that's the storage array that's tagging it or a Cisco UCS server that's tagging it. We use a tag so that the Nexus device or the UCS device in question doesn't have to drill deep into the packet. We simply look at the tag and say, oh, you're tagged with 2 or 4 or 5 or what have you. And we know that we're going to treat traffic that's tagged that way in a particular fashion. So in this video, we'll jump in and explore how exactly we can leverage classification and marking in a UCS environment. Let's get started. Quality service is a network's method for favoring one traffic type over another. We can imagine we might have a network switch here, and we've got all kinds of downstream connections with all kinds of traffic flooding up these links, and then we have one pipe up here, and we like to oversubscribe our networks. I mean, that's okay. That's a big part of it because not everybody needs, for example, a 1 gig connection downstream. But when we put all of these different traffic types onto this one connection, well, we're going to have contention problems. And this is especially true when we think about traffic types such as voice over IP. Voice over IP is extremely latency sensitive, plus they're really small frames. And so when we're sending them onto the link, we've got maybe these very large data transfer packets, and they're 1500 bytes in size. We've got this teeny tiny little VoIP packet behind it, and we have to wait for this packet to be sent before we can even send our VoIP packet. And that's not great news. And so we came up with this idea of quality of service. We've got different queues. We can place our traffic into the different queues. And so now our VoIP traffic is up here and our big bulk data traffic is down here. And so our scheduler is able to grab a packet from the voice queue and send that on its way, even if a very large data packet down here had happened to arrive first. And the way UCS works is it's going to look at the class of service. The class of service is a way of marking a packet in the layer 2 header to tell us how that packet should be serviced. And the question is this: how does this switch on this interface know that it's a voice over IP packet? Is it actually looking at it and trying to figure it out? For the most part, no. The packet is going to be tagged. And we can tag the packet a number of different ways. Outside of the data center, we like to use something we call Differentiated Services Code Point, or DSCP. And way back in the day, we used a concept called IP precedence, which has more or less been deprecated. And so now we're using DSCP instead of IP precedence. Both of these are in the IP header. But we know in the data center, we love our layer 2 domains, and we love Ethernet. And so we're going to use class of service, which shows up inside of the Ethernet header. Now, a big part of this is the understanding that it doesn't just show up inside the Ethernet header, it shows up inside of the VLAN tag inside of the VLAN header. And if you're tracking with me on this, you might realize, well, wait a second, the VLAN tag doesn't always show up on a link, so does that mean that we sometimes don't get class of service tagging? And the answer is yes. That is correct. We do not always get it. Specifically, we require ourselves to be on trunk links in order to see the class of service tag. And so if we're sending traffic untagged across a line, that means we have no VLAN tag, which means we have no class of service tag. Now, class of service is a 3-bit field, and 3 bits gives us 8 values. And so our values are going to be from 0 all the way to 7. So 0, 1, 2, 3, 4, 5, 6, and 7. Now, 6 and 7 are reserved. These are reserved for network traffic. We're going to use that internally for very important traffic. We're going to use it potentially between switches for routing protocols and such. We don't need to worry about those values. Now, 0 isn't technically reserved. However, we do use it already for what we call best effort traffic. Best effort traffic is effectively going to be the default traffic patterns that we get, so anything that isn't tagged with a different value. Furthermore, we typically reserve 5 for voice over IP. Now we start to get into an interesting conversation. Because inside the data center, do we actually have voice over IP packets? The answer might be yes, and the answer might be no, depending on your environment. In a lot of cases, we might have voice servers. So if we have servers inside the data center that might be sending voice traffic, well, then we might consider that we're going to see some of that. Just to make matters a little bit more complicated, we might actually get the voice control traffic. And so voice control traffic has a COS of 3. And so we might be more likely to see 3 in the environment than 5, which is going to cause us a little bit of grief here, and we'll explain here in a few moments. Now, 1 is typically reserved for what we call the scavenger class. Scavenger class is the idea that we really don't care about this traffic. If we were to drop anything in the environment, we should first drop scavenger class traffic. And so maybe we assign that to applications that are part of research and development, or potentially to just applications that we understand that they are not business impacting. And if we were to have network congestion like we have on this interface, then let's just drop all of the scavenger class traffic first, and then we'll start to arrange and try to figure out what other traffic we need to drop. But we're down to just a few tags left really for us to customize, but I will say this, if we're going to use fiber channel over Ethernet in our environment, it defaults to a class of service of 3. And this is the problem that I mentioned earlier, that we might actually have voice control traffic that's getting tagged with 3 as well. We are going to have to work that out with our voice teams to say, hey, we actually need to use class of service 3 for fiber channel over Ethernet, and so we're going to need you to tag your traffic with something else, which I'm sure that's going to be a fun conversation, but at the same time, one of us is going to have to change, because we cannot send voice control traffic into the same queues as something as mission critical as fiber channel over Ethernet. So that leaves us with 2 different tags we are very likely to be able to use inside the data center. So what are we going to use it for? Well, 2 of our primary applications are going to be iSCSI traffic, which is storage, as well as live migration traffic. Live migration traffic, it consumes a whole lot of bandwidth inside of our data center. And so we might actually need to dedicate a tag to live migration traffic in order to give us quality of service control over it. So maybe we apply live migration to a COS of 2. But then iSCSI here, the question is going to be, are we using iSCSI and fiber channel over Ethernet? Because if we're not using FCOE, then maybe we can assign iSCSI to 3, and that keeps 4 available. Otherwise, if we're using both, maybe we have to assign iSCSI to something like a COS of 4, at which point we don't have a whole lot of flexibility for other applications. So as we can see here, it's going to be a conversation. We need to decide which of our applications should be considered as part of this policy. Keeping in mind that a lot of our applications are going to be here inside the best effort class. However, we might have other applications that are either bandwidth sensitive or latency sensitive. And if we have applications like that, then we're going to need to give them some kind of tag in here in order to apply better policy to it. Now, one thing we need to be aware of is that when we get onto UCS to do the actual configuration of our classes of service, we're going to find that Cisco likes to refer not to the value, but to a particular traffic class. Now, within the world of UCS, they define several different traffic classes that we need to have memorized. These traffic classes are known as Platinum, Gold, Fiber Channel, Silver, Bronze, and Best Effort. Whenever we are doing quality of service configuration somewhere in UCS Manager, it's going to talk about these traffic classes. So everything we just talked about over here on the right, this is all valid, except when we're talking about best effort, for example, we actually use that phrase best effort right here, it's going to be referring to a class of service value that is not necessarily referenced at the time. So I might be configuring a QoS policy, and it says, okay, which type of traffic class do I want to map this to? And we use a drop-down menu, and in that drop-down menu, it lists all of these. So if I know that I want to map a COS value of 2, for example, to this particular QoS policy, then which of these traffic classes am I supposed to choose? This is why it's important that we have the mapping memorized, even though we can technically rearrange this if we want to. So by default, the Platinum class is referring to a COS value of 5. Gold is a COS value of 4. Fiber channel is 3, and you're probably starting to notice the pattern here of why I listed it out the way it was. You might have wondered why in the world I included fiber channel between gold and silver. Well, this is why. Silver maps to 2. Bronze maps to a COS value of 1, and best effort, technically we could say 0 here, but that's not the most accurate answer. This is the catch-all. It's going to catch anything that wasn't caught by one of the above traffic classes. So using this drop-down policy up here, if I wanted to, for example, again, pick COS value of 2, then I would need to use this drop-down to select a silver policy. Now, once again, we can rearrange this if for any reason we want to. And one of the reasons might be, by the way, this FCOE conversation. I might want my FCOE to use a class of service value of 4. And at that point, my gold would have to use a COS value of 3. And so I might have to swap these two numbers in order to make my data center policy work. However, by default, these are the values that are assigned, and generally speaking, we want to keep this default setting if it's at all possible to do so. So as we review this, quality of service is going to rely on the concept of packet tagging. And as we saw, there's many ways of doing that, including DSCP and COS. Now, because we love layer 2 inside the data center, UCS is going to rely on COS, which is class of service. Now, there are 3 bits in the class of service field, and so we've got 8 different values, and as we saw, that only does show up on trunk links, so we need to be careful with it outside of our UCS domains. And lastly, UCS is not going to necessarily refer to the COS tag itself in various QoS configurations, so we need to have that traffic class memorized. We need to know, for example, that Platinum maps to COS of 5 by default. I hope this has been informative for you. I'd like to thank you for viewing.